Now in this video, we'll discuss about how do you output a matrix. Now as I have mentioned in the earlier video, let's say we have a 5 by 5 matrix. The coordinates is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on and so forth for the rest. Now when you want to display matrix, we intend for it to display line by line. Means let's say I display the matrix of 0, 1, 0, 2, 0, 1, 0, 0, 0, my bad, 0, 1, 0, 2, 0, 3, 0, 4. Okay, now we have 5 here, right? Then we expect it to go to the next line. Then we continue on and on again. As you can see, the subscript that denotes the row stays the same. Now the only thing that will change is this one. Notice. And once this reaches at the end, it goes to the next line. So we can use a nested for loop again for this one. I'll just write a part of the code over here. So for int I is equal to 0 and I is smaller than 5. We'll assume that this is a 5 by 5 matrix and I plus plus. Alright, now we have the next one, which is for int j equals to 0, I is smaller than 5, and j is smaller than 5, and j plus plus. Alright, so in here we're going to display everything. So let's put printf. We assume that this matrix is a float data type. So we're going to display, and we assume that it's mat a the same, I, j. Then we're done. And next we're going to put printf \n. Okay, so see what this does is that I denotes the row, j denotes column. So right after we finish displaying the whole row, we have a new line with this \n, and it goes up again. And you can actually view this in a previous video, which I've explained about nested loops and how it works. But this is the whole piece of code to actually display matrix, be it a 3 by 5 matrix, 100 by 1000 matrix. It's still the same way to actually display it. The only difference will be this. This, as I've said, denotes the number of rows. If it's a 3 by 5 matrix, this 5 is supposed to be a 3 and this 5 stays still. 3 rows and 5 columns. Alright, now I'll go into detail about determinants. Now the determinant of a matrix A, B, C, D can be denoted as A times D minus C times B. I might have made a small mistake here, probably it's C times B minus A times D, but we'll just assume that determinant is actually found this way. So we assume that it's this. Now next, have a look. These are the coordinates. By the way, determinant in this fashion can only be found with a 2 by 2 matrix. If it goes up to a 3 by 3 or anything above it, we cannot use this method to find anymore. But we're going to keep it simple and leave it as a 2 by 2 matrix. So to find a determinant, the name of this is matrix A. So let's say determinant determinant of A is equals to matrix A. Now A times D, this coordinate times this coordinate, 0, 0 times mat A 1, 1 minus matrix A. Now C times B, so it's 1, 0 times 0, 1 minus 1, 0 times matrix of A 0, 1. So this is how we denote determinant of A. We can make use of these coordinates. Now this is relatively simple, it's not that difficult. So we'll move on to the next one, which is transpose of matrix. Transpose is somewhat difficult compared to determinants. Now look, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, if I were to transpose this, let's say this is A, so A transpose will be equals to, let me use a different color. I take the first row and put it as a column. The second row, I put it as a column. Third row, I put it as a column. So this is what it means by transpose. So let's talk about the coordinates of each of them. I love talking about the coordinates. So 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Alright, so the A transpose will be equal to 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So let's look at the, how do you say, the what's the word? Let's look at how it actually goes in the transpose. Now 0, 0 stays in put. Now compare this A original with A transpose. What's the difference? They switch the place. How about this? It's the same. If you compare these two, they actually switch places. Now let's take a random one. This 21 and 1, 2, they switch places. Now 20, 2, 0 and 0, 2, they switch places. Now these coordinates, this is how they switch places. So in order for us to create a code that can actually transpose it for us, we use a for loop. For int I. Now you notice that usually in arrays we have to use for loops because it's how we can actually use them, manage them in a more efficient way. So I, let's say, is smaller than 3. Let's make it a 3 by 3 matrix, and I++. For int j is equals to 0. Sorry, equals to 0. Semicolon. J is smaller than 3. Semicolon. J++. So how do we transpose it? We have to transpose it in a way like this. Okay, so transpose A I j is equals to mat A j ji. So there you have it. This is the code to transpose a matrix. So let me explain what it does. Now let me draw it here again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is matrix A, and this is A transpose. Let's see if this program works. Now I'm saying that at the transpose coordinate of ij is equal to the matrix coordinate of ji. So I is 0, right? And it enters the second loop. Then j is 0. So I'm saying that at the location of transpose A, coordinate 0, 0 is equals to, for matrix A at the coordinate 0, 0, right? So I'm saying that 1 is here. And then this loops again. So j becomes 1. J becomes 1. At the coordinate of transpose A, 0, 1, row 0, 1, this number 2. Sorry, I'm talking about this for this one. Transpose A, 0, 1 is equals to matrix A, 1, 0. 1, 0. This is 1, 0. Remember? 0, 0, 0, 1, 0, 2, 1, 0. So 4 is 1, 0 at the coordinate. So this is 4. Next, when it loops again, j becomes 2. So j is right now, j is 2. I'm saying that 0, 2, which is this, is equals to matrix A of 2, 0. Remember, this is 2, 0. So I'm saying that this 7 is here. Then it loops again. When it's out of this loop, actually no, j becomes 3, and 3 is larger or equal to 3. It doesn't correspond with this condition. So it gets out of the loop, and now it loops again in the outer loop because I is 0. So now I becomes 1. I becomes 1. Comes back in here. J becomes 0 because it comes back to, it re-enters the loop. So j is 0. J 0. I'm saying that 1, 0, which is this 1, 0 of transpose A, is equals to 0, 1 of matrix A. 0, 1 is this 2. Then it loops again because obviously 0 is lesser than 3. It loops. Now j becomes 1. Transpose A, 1, 1 is equals to mat A, 1, 1. So this is 1, 1. Coordinate 1, 1. And for this, it's also 1, 1. So it's 5 over here. It's 5. Then it loops again. J becomes 2. 2 is smaller than 3. It stays in here, comes down here. So I'm saying that transpose A, 1, 2 is equals to matrix A, 2, 1. Transpose A, 1, 2. This coordinate is 1, 2. Is equals to matrix A, 2, 1. This is 2, 1. So it's 8. So I'm not going to complete this. You can see where will it go, the pattern of it. So this is actually the whole code you need. And try to keep watching this video until you understand how to transpose a matrix and the logic behind doing this. So I hope you have a good understanding on the coordinates of matrix and how to use them to find determinants in a 2 by 2 matrix and to actually transpose a matrix and displaying matrices. So I'll see you in the next video where we'll discuss more advanced applications of for loops and two-dimensional arrays on matrices.